So in this short video, let us see that how we can implement the realize the digital filter by direct form 2 type of realization. So for this, let me consider again that equation y of n. Let's take direct form 2 realization. So again, I'm going to consider the same equation. Y of n is equal to minus summation of k equal to 1 to n ak y of n minus k plus summation k equal to 0 to m bk x of n minus k. Okay, so again I'll now in this case, just since I want to modify this, let me take the definition of h of s, which is nothing but y of z upon x of z. Now I'm going to introduce one dummy variable here, y of z by x of z into w of z by w of z. So which further I can write as the x of z and w y of z by w of z into w of z by x of z. Okay, so now with this, what I have is I have the provision for selecting certain terms. So in what way I'm going to take it here is now okay, now this is nothing but summation k equal to 0 to m bk z bar minus k divided by 1 plus summation k equal to 1 to n ak z bar minus k. So now what I can do here is let y of z by w of z, I can take it as summation k equal to 0 to m bk z bar minus k and w of z by x of z is equal to so I can write this one, there will be 1 plus k equal to 1 to n bk sorry ak z bar minus k. So what is the benefit I get here is I can write both the set in terms of the delayed versions of w of z. So let us take this y of s is equal to summation k equal to 0 to m bk w of z into z bar minus k, and I have this x of z is equal to w of z plus summation k equal to 1 to n ak w of z into z minus k. So now in this case, what happened, you can see this in the actual expression we have the delayed samples of output and the delayed samples of the input. Now we have an intermediate variable w of z which is going to be delayed common, and it is going to derive both your input and output function. So what is the benefit we get out of this? So before that, let me take this inverse one. So taking inverse Z transform, we have y of n is equal to summation k equal to 0 to m bk w of n minus k, x of n is equal to w of n plus summation k equal to 1 to 1 to n ak w of n minus k. So in both the cases we have this w of n as a delayed version. Okay, so now let us draw the diagram for this. So I have x of n as a sum of w of n plus minus a1 times of w of n minus 1 minus a2 w of n minus 3 minus a3 and similarly I can have this till minus a n z power minus 1. This is my nth delay element, and similarly from this I need to find out that y of n, right? What is y of n? Y of n is a summation of these terms, and that is wn delayed, right? So let me have this b naught y of n w of n so here multiplied by b1 b2. So bm z power minus 1. So this is individually we realized this. So here I have will be having w of n minus m, and here we'll be having w of n minus n. Okay, and so here what is the benefit we get here? Since here if you take the midway, If you take this part, this section here in this is identical. It's identical. So what is the benefit we get this get through this is we can combine these two and we can have a single structure, which we are going to have it now here. X of n multiplier y of n. Let me take this w of n so let me I'm simply what I'm doing here is I'm just combining b naught, b2, b3 and bm, and it's been terminated like this. And similarly here minus a1 minus a2 minus a3 minus an. I can have an adder over here. I can write this is minus a m. In all the cases, I need to draw the direction of the signal, which I am going to make it here. Okay, so what is the benefit we get through this direct form 2 implementation is we were in a position to minimize the total number of delays to only n. In the previous case, we had the memory locations of m plus n plus 1, but now in this case, since we have the provision to have combined the delays, and also we have this m is less than or equal to n always for realization filter. The number of memory elements or the delay elements required here in this case is the maximum of n, which is more in the direct form 1, and it is equal to m plus n plus 1. Now this much memory elements is now minimized. M plus 1 memory elements are now not required in this form of realization. That's why we go with this. But again, if the number of the order increases, then it will be a very long vertical structure for implementing. So this is one drawback what we have with the direct form 2 type of realization of a digital filter.